This is a video for Ivy Tech's Math 123 Quantitative Reasoning class. I'm going to show you how to use Excel to make a graph of simple versus compound interest. You will find the instructions for this in currently what is section 20 of our book, Simple and Compound Interest. And in the current edition, this starts on page 183 of the text and walks you through it step by step. So I'm going to do that. I'm also going to add in a little bit of extra information for tips and tricks on how to use Excel and using its what I call the drag feature. I think it's really called the copy feature for our cells. So I've already started an Excel sheet for us, and all I've done is typed in the headers. I haven't put any formulas or numbers in so far. So let me start by showing how to use the copy feature by making a list of years. So we want to look at a 30-year investment of $100 at 11% interest, which is a very high interest rate, but we'll use it for demonstrative purposes here. Okay, we're going to think of that first year as being year 0, and then the next year would be year 1. And certainly I could type out all 30 numbers, but I don't need to. Excel can help me create a list of consecutive numbers. Okay, to do that, I want to establish a pattern. So I can't just type 0 and drag it because watch what happens. It thinks I just want to copy 0. So to establish that pattern, I have to type at least 2 numbers. I have to highlight both of those numbers. I have to grab just the corner here and make a black cursor button. And as I start to drag it down, there's a little ticker off to the right there that tells me when I get to 30, so I can see that I need to stop there. Okay, so we're going to use that drag function again to create columns for our simple interest each year and our compound interest each year. But to do that, I need to establish some additional information. So you can see we've created some boxes here for APR and the simple interest that we earn. And there's actually several ways that we could achieve the information for this graph, but I'm going to try and follow what's in the book. Okay, so let's start with our APR. It's 11%, but to tell Excel 11%, I have to tell it 11% in decimal form. So 11% is 11 hundredths, but I can make it look like a percent by selecting that feature and the number area up here in my ribbon. Okay, so our APR is 11% whether we're looking at simple or compound interest. When we look at simple interest, though, simple interest is just principal times rate times time, and in simple interest we earn that same interest value every single year. So let me first establish our investment. Our investment is $100 for both accounts. And again, I can format those as dollars. So my simple interest on each one of these accounts, I can have Excel calculate. So I'm going to tell Excel equals, and I'm going to use B5 times E2. So with simple interest at 11%, I'd earn $11 every single year. Okay, so if I come here to my simple interest column, one way to have a list of information would be to tell Excel that for year 1, I'll have my $100 in cell B5 plus my simple interest in cell E3. Now, this will work great for the first year. I get $111 just like I'm supposed to. But let me go ahead and make a mistake here, because this happens to me all the time in Excel and it's very frustrating. When I try and drag this information, Excel doesn't do what I expect it to do. What I wanted to happen in this next year was to add $11 again. So what went wrong? Well, Excel, when I drag, it thinks I want to use what's called a relative reference. So if I had B5 in the cell, now it changes to B6 and the next cell changes to B7. Well, that is what I want for the cells in column B, but it's not what I want for the cells in column E, because you can see what's happened here is it thought you wanted cell E3, now you want cell E4. Okay, so how do I fix that? Well, it's using what we call absolute and relative references. We want cell B5 to be a relative reference that changes, but we want the cell E3 to be referenced every single time. So one way to achieve that is you type dollar signs in front of the E and dollar signs in front of the 3. And what this tells Excel is fix column E and fix row 3 and use that same cell every single time. So that's a little different than what we explain in the book, but you can see it works very well. In fact, this is such a common thing that Excel has a built-in feature. If I highlight E3 there and hit my F4 key, my function 4 key, that's will put the dollar signs in for me. And if you're using a Mac, there's a special button for you to hit as well. Okay, we even explain a different way in the book though. Cell E2 and E3 are so important, what we suggest in the book is to give them a variable name. So how do I know this is cell E3? Well, it's located in column E, row 3, but it also has over here the information that tells us the name of the cell, a little call box here. You can actually change that. In fact, in the book we suggest you change this one to the variable simple. You have to type it in and hit enter. Any place I type the word simple in the spreadsheet will refer to cell E3 instead. Now there are some rules. I can't name it anything I want. I can't name it something that's already used in Excel. I couldn't name it SUM. That would be too confusing. Okay, so if I take cell B5 and I type plus and I start typing in simple, Excel actually recognizes that as a variable name. Okay, once again I can drag this down. You can also, since we've established that it will stop at 30, if you double click on the corner, it will copy the cells down to wherever the cells in the previous column ended. Okay, so we've got our simple interest. So let's do kind of the same thing for compound. Again, in the book we suggest renaming cell E2. Since it's our APR, we'll rename it APR. I have to hit enter to make that name take. Okay, so there's a couple ways we could figure out compound interest. Compound interest should take your investment and multiply it, and you have to use an asterisk here, times 1 plus our APR. So in year 0 you'd have $100. In year 1 you would have 1.11 times $100. We are assuming that we're compounding annually here. Okay, if I drag this down, what happens? Well, my C5 reference is a relative reference, so on the next cell it says take C6, multiply it by 1.11. In the next cell it takes C7, multiplies it by 1.11. Now at first, we don't see much of a difference between our investments. But in simple interest, we add the same $11 each year. In compound interest, we're multiplying, and eventually that multiplication will result in a much larger value being in the compound interest area. Now that's not the only way I could have done compound interest here. When we think of our compound interest formula, we think of it as our principal. So I almost started to type 100 here. If you want to use a cell reference, you can. But my principal will be 100 for all of this. So I could use my cell reference and make it absolute and say $5. And so we usually take our principal times 1 plus our APR. And we usually raise it to an exponent. Well, my exponent is my number of years, which we've established a pattern for. Now notice I didn't fix my number of years here. Let me make this dollars. So as I drag this down, it's going to reference to whatever year we're in every single time. But it's going to keep my $100 reference fixed, and you can see I'm getting exactly the same values. So it's just another approach to getting compound interest. Okay, well I thought the point of this video was to show you how to make the Excel chart. So it's very easy. I'm actually going to highlight all 3 columns, the year, the simple, and the compound interest. I'll come up here to insert, and I want the last choice on the list. I'm going to use a scatter plot, and it's going to make a little dot for each year the value of its investment. I'm going to rename this chart simple versus compound. And you can really see it here in the visual that at first the dots are the same, but then the compound interest, because you're earning interest on top of interest, that multiplying really causes that compound interest to take off in what we call an exponential growth. How much it takes off depends on what your interest rate was. So we already have a very high interest rate at 11%, but let's see what happens if I change that APR and make it even higher. So I'm going to enter 15 and all my numbers are going to change and my chart's going to change. And we're going to see that it's even steeper. Or if I were to go even higher and make it 20%. Okay, at 20%, we can start to see that the simple interest now looks like it's not growing at all. The compound interest is shooting off exponentially. So this is what makes Excel really fun. We can easily change the numbers, play around with it. If you make a mistake, don't get frustrated. Just undo whatever you did and try again. So I highly encourage you to work through this example.